Now we start exercise 2.10, and the question number 1 is find two positive integers whose sum is 30 and the product will be maximum. This exercise is actually the practical applications of maxima and minima related to our daily life problems. So the first problem of the first question is we have to find two positive integers whose sum is 30 and their product will be maximum. We have to choose such two positive integers which make the sum is 30 and the product should be maximum. For example, we can take two positive integers 1 and 29. Obviously the sum is 30 but the product will be 29 because 29 into 1 will be 29. And similarly we can select two positive integers 2 and 28. Again the sum is 30 but the product will be 56, and you can note the thing that in case of 1 and 29 the product is 29, and in case of 2 and 28 product is changed. The sum remains 30 but the product is changed now, which is 56. And similarly we can select two positive integers 3 and 27. Again the sum is 30 but the product is again changed and become 81. So we can repeat this process until unless we can get a maximum product. But if we do it manually, then that will become a very lengthy process. Or if the sum is 30, we can replace the sum is 30 by 300 or 3000. Then by choosing two positive integers manually, then that will become a very lengthy process. So we use our differentiation process or technique of maxima and minima to find the product which make maximum of that two numbers, the product of that two numbers. Solution: let the first positive integer is x and the second positive integer is 30 minus x. Obviously the sum is 30, and as we discussed in examples that if we choose first number is 1, then second number must be 29. So that will become actually 30 minus 1, which is 29. And if the first positive integer is 2, then the second positive number must be 28, which will become like 30 minus 2, which is 28. So this is the scenario to get let our two positive integer, the first is x and the second one will become 30 minus x, so that the sum will become 30. According to the condition, product is x into 30 minus x. Product of these two numbers which we selected in our supposition, that first integer is x and the second integer is 30 minus x, then their product will become x into 30 minus x. So this will become after simplification, product is 30x minus x square. Now differentiate with respect to x. So dp by dx is equal to 30 minus the derivative of x square will become 2x. Again differentiating, the second derivative will become d2 by p by dx square is equal to derivative of 30 is 0 and derivative of minus 2x is minus 2. And for stationary points we make first derivative is equal to 0. So put dp by dx is equal to 0, so that we can get that particular value which make the second derivative positive or negative. as we discussed in exercise 2.9. So 30 minus 2x is equal to 0, and from here we can get the value of x, which is 15. Now we put this x is equal to 15 in second derivative, so that we can check either the second derivative is greater than 0 or less than 0. If second derivative is greater than 0, then the function whose second derivative we are going to discuss, if the second derivative is greater than 0, then the function will be minimum, and if the second derivative is less than 0, then the function will be maximum. So put x is equal to 15 in d2p by dx square in second derivative. Actually we get d2p by dx square is equal to minus 2, which is less than 0, and at x is equal to 15, the second derivative return a negative integer or negative value, then the function p, whose second derivative to be discussed, that function will be maximum at x is equal to 15. And as our required condition was, we have to make the product should be maximum. So our first positive integer, which we declared x, and we found the value of x is equal to 15, and the second positive integer was 30 minus x. So put the value of this x, 30 minus 15, and the second positive integer also become 15. Hence we can say that the sum of these two positive integer is 30, but the product is maximum in all the cases which we can select two integers whose sum is 30. For example, 1 and 29, sum is 30, but the product is 29. 2 and 28, sum is again 30, but the product is 56. 3 and 27, again the sum is 30, but the product is 81. So it can easily say that the sum remains 30, but the product is going to be changed in every case. So repeat this process. We found here 15 and 15, whose sum is 30, but the product is 225, which will return maximum in all possible cases. So this is actually the practical application or the usage of maxima minima second derivative test. We can easily evaluate the maximum or minimum value by doing this process, instead of checking the two numbers manually, as it already discussed that if we talk about the sum is 30, then that is almost simple case doing manually. But if the sum is 300 or sum is 3000, then that will become lot more difficult to find the product which will return a maximum value. So this one is the question number 1.